A-level statistics, measures of spread, range and quartiles. Let's see what we mean by a measure of spread. Consider three groups of people with the following ages. Group A has ages 3, 5, 11, 12, 16, 17 and 20. Group B has ages 9, 10, 12, 12, 13, 13 and 15. And Group C has ages 1, 11, 12, 12, 12, 13 and 23. Now we can see these groups if we show them on a number line. Now each group has a mean of 12 and it also has a median of 12. So those two averages are identical. However, if we consider how spread out the numbers are, we see they're quite different. We see the numbers in set B are grouped much closer together than those in group A. In set C, the numbers are the most spread out if we look at the first and last points, but other than these, they're the closest packed. So what we need is a method of measuring how spread out the numbers are. Now one method we use is called the range. The range is the difference between the largest and smallest value in the data. So the range is equal to the maximum value minus the minimum value. In group A, the smallest value is 3 and the largest value is 20, so the range is 20 minus 3, which is 17. In group B, the numbers go from 9 up to 15, and so the range is 15 minus 9, which is equal to 6. And in group C, the numbers go from 1 up to 23, so the range is 23 minus 1, or 22. So we see group C has the greatest range, followed by A, and then B. However, apart from the two extreme values of the data, the range tells us nothing about the layout of the rest of the data. So, for example, C has the greatest range, although the majority of its values are much more tightly packed than the majority of the values in either A or B. The range only tells us about these extremes. It tells us nothing about the central values. Now if we consider group data, if the data is grouped, we can only estimate the range. The problem is we don't know what the maximum and minimum values are, only the groups that they're in. So we have to assume the range is the difference between the lower and upper boundary values of the data. All we know in the table is that the value of x lies somewhere between 30 and 70. So we have to take the range as 70 minus 30, or the range is equal to 40. This is only an estimate because we don't know the actual values of x. An alternative way of calculating the spread is to consider what we call the quartiles. If we've got a sorted list of data, the median divides it into two equal groups, above and below the median. The quartiles further divide each of these into two equal groups. The lower quartile is a quarter of the way through the list, the median is halfway through the list, and the upper quartile is 3/4 of the way through the list. If we consider again the ages of the three groups of people, A, B and C, we see the median in each group is 12. Now, if we consider the groups on either side of the median, that is 3, 5, 11 and 16, 17, 20, we can find the median of each of those groups. Now in the bottom half it's 5 and in the top half it's 17. So we define the lower quartile as being 5 and the upper quartile as being 17. Now in group B, the lower quartile is 10 and the upper quartile is 13. And in group C, the lower quartile is 11 and the upper quartile is 13. Now we can define the interquartile range, or the IQR, as the difference between the lower and upper quartiles. So in the above examples, in group A, the lower quartile is 5 and the upper quartile is 17. So the interquartile range is 17 minus 5, which is 12. In group B, the lower quartile is 10 and the upper quartile is 13. So the interquartile range is 13 minus 10, which is 3. In group C, the lower quartile is 11, the upper quartile is 13, and so the interquartile range is 13 minus 11, which is 2. So in this case, A has the largest interquartile range and C has the smallest. Now that shows that C, although it's got the largest range because it's got two extreme values, the rest of the numbers are quite closely packed. So the interquartile range ignores extreme values and looks to see what's going on with the central section. Quite often it's useful to have both the range and the interquartile range. Now the question is, how do we find the quartiles? If we've got a set of data, to find the quartiles, the first thing we must do is make sure we put the list of data in order of size. We then find the median. Now this is the n plus 1 over 2 term. If n is odd, there is a median term. Now we ignore this and we look at the terms below and above it. We then find the medians of each of those two sets. These are the lower and upper quartiles. If n is an even number, then the median lies between the n over 2th term and the n over 2 plus 1th term. We divide the set into those below and those above the median, and then find the median of each of these sets. These are the lower and upper quartiles. So for a couple of examples, find the quartile of 2, 3, 5, 5, 7, 8, 8, 9, 11, 12. This has 10 terms. Because n is even, the median lies between the 5th and the 6th term. That's 10 over 2 and 10 over 2 plus 1. This means the median is between 7 and 8. So if we draw a line between the 5th and the 6th term, that divides the list into two sets. We then find the median of the left-hand side, which is 5, and the median of the right-hand side, which is 9. So the lower quartile is 5 and the upper quartile is 9. In part B, we've got the numbers 1, 2, 2, 4, 5, 7, 8, 12 and 13. Now in this case there are 9 numbers, so there is a median. Now to find the median, we want the n plus 1 over 2th term. That is the 9 plus 1 over 2, the 5th term. So the 5th term is 5, so we eliminate 5. Now on the left-hand side we've got the numbers 1, 2, 2, 4, so the median is the mean of 2 and 2, which is 2. And on the right-hand side, the median is the mean of 8 and 12, which is 10. So we get the lower quartile is 2 and the upper quartile is 10. Now let's introduce some notation. We label the lower quartile as Q1, we label the median as Q2, and we label the upper quartile as Q3. If you look at the example, we've done a stem and leaf diagram, and we have to find the median and the quartiles in it. Now to solve it, we can count the number of leaves that there are, that's 16, and so there are 16 elements in the set. So the data is divided into 4 sets of 4. So Q1 is between 23.6 and 24.2. So Q1 is the mean of those two numbers, 23.6 plus 24.2 divided by 2, which is 23.9. Q2 is between 25.1 and 25.6. So Q2 is the mean of those, 25.1 plus 25.6 divided by 2 is 25.35. And Q3 is between 25.8 and 26.3. So Q3 is 25.8 plus 26.3, all divided by 2, which is 26.05. So our answers are Q1 is 23.9, Q2 is 25.35, and Q3 is 26.05. Let's have a look at another example. Again, we've got a stem and leaf diagram, and we have to find the medians and quartiles of it. Well, to solve this, the first thing we do is we count how many leaves there are, and that's 21. So there are 21 terms, and so the median is the 21 plus 1 over 2th term. Now 21 plus 1 over 2 is 11, so the median is the 11th term. That gives us that the median is 520. We now ignore this term and find the median of the two sets on either side. Now there are 10 numbers in the lower half, and so the median of the lower half lies after the 5th number. That means Q1 is the mean of 420 and 430, which is 425. Now Q2 is the median that we originally found, which is 520, and Q3 is the median of the top half. Now there are 10 numbers in the top half, which means the median lies between the 5th and 6th. That is between 660 and 660. So the upper quartile is 660. So we have the lower quartile, Q1, is equal to 425. The median, Q2, is equal to 520. And the upper quartile, Q3, is equal to 660. Now let's see how we can deal with group data and quartiles. If we have group data, it's a good idea to estimate the quartiles from a cumulative frequency graph. For example, draw a cumulative frequency graph for the following data and find the median, the quartiles and the interquartile range. Well, to solve this, we need to add a column for the cumulative frequencies. Now, the cumulative frequencies are 3, and then 3 plus 12, which is 15, 15 plus 24, which is 39, 39 plus 23, which is 62, 62 plus 15, which is 77, 77 plus 13, which is 90, and 90 plus 10, which is 100. And we can now draw out a graph grid. It needs to stretch from 20 to 90 on the x-axis and from 0 to 100 on the y-axis. Now it's a good idea to circle the 20 as a reminder to plot the point 20, 0. We can then plot the points. Now they are 20, 0, 30, 3, 40, 15, 50, 39, 60, 62, 70, 77, 80, 90, and 90, 100. We can then join them with either straight lines or a smooth curve. Now, there are 100 numbers in the list, and for the lower quartile, we want to go a quarter of the way through the list. So that means 25, which is a quarter of the way up the y-axis. The median is halfway through the list, which is halfway up the y-axis. And similarly, the upper quartile is 3/4 of the way through the list, and so it's 3/4 of the way up the y-axis, in this case at 75. Now from halfway up the y-axis, draw a line across to the graph and down to find the median. And that gives us a median of 54.5. From a quarter of the way up the y-axis, draw across to the graph and down, and that gives us 44.7. So the lower quartile is 44.7. From 3/4 of the way up the y-axis, draw across to the graph and down, and that gives us 68.6. So the upper quartile is 68.6. Now that gives us an interquartile range of 68.6 minus 44.7, which is equal to 23.9. So we've got a median of 54.5, a lower quartile of 44.7, an upper quartile of 68.6, and an interquartile range of 23.9.